Alright, welcome back to AutoDraw. In the previous video, you learned how to draw your first perfect square with code. Now, in this video, I'm going to show you how to draw many other kinds of perfect shapes. In particular, we're going to take a look at triangles and hexagons and octagons, and finally, we are going to draw our first perfect circle with our sprites, something that it's very hard to do by hand. Okay, so we are going to make the sprites draw these things automatically for us. Now, if you remember in the previous video, we drew a square by moving a few steps, turning 90 degrees, and repeating this 4 times. Now, I'm going to ask you a question. How many total degrees did we make the sprite turn? All right, take a second, look at the script, and try to answer how many total degrees did we make the sprite turn in total. So, if you take a look at the script says turn right 90 degrees 4 times. So if you add 90 degrees plus 90 degrees plus 90 degrees plus 90 degrees, the total will be 360 degrees. We mentioned that in the previous video. 360 degrees means a full rotation back to its original position. Now, the interesting thing is that 360 degrees can be obtained in multiple different ways. We've just obtained it in this way by turning right 90 degrees 4 times. So I'm going to change the script to do the exact same thing. So I'm going to break it after the first move and turn block. And I'm going to add a repeat block which wraps these two. So I'm going to say repeat 4. And I'm going to keep these 2 blocks inside. So instead of having all these blocks repeated, I'm just going to repeat 4, and I'm going to keep those 2 blocks there. And I'm going to remove the rest. So notice that we can obtain the exact same effect by adding a repeat loop. So if I hit the flag and I press the A key, notice that the sprite automatically created the square as we saw it earlier. Now, the interesting thing is that 360 degrees, which is a full rotation, can be obtained in many, many different ways. Here's how I'm going to do it. I'm going to click the flag so that we can clear the canvas, and I'm going to right-click and I'm going to duplicate this script. So I'm going to put it right next to the script that we created earlier. And I'm going to say when the key B clicked, so that we respond with this script when we click a different key. I'm going to simply keep most of this code saying pen down and the repeat block, except I'm going to change the number of repetitions. So I'm going to say repeat 3 this time around. And instead of 4 rotations, we have 3. And I'm going to aim for the exact same 360 degree full rotation. Now, if you know some math, 360 degrees divided by 4 is the 90 degrees that we obtained earlier. Now, if you do 360 degrees divided by 3, you will obtain a different number. And this number is 120 degrees. 120 degrees means more than a straight angle. So the sprite will move to the right, and then it will rotate 120 degrees, which is a little bit more than the regular straight angle. Now, just to make things a little bit more interesting, I'm also going to change the color of the pencil to a different color. Maybe black is a little bit boring to you. So I'm going to go to the pen and I'm going to add set pen color to something else. So I'm going to put it right underneath when B key pressed. And I'm going to pick a color. I'm going to choose a red color. You can choose any color that you like if you fancy it. Now, I'm going to hit the flag and I'm going to hit the B key to see what we obtain. So notice that this time we obtain a perfect triangle. Now, why are we obtaining a triangle? Well, because we're repeating 3 times a move block, so we're moving 100 steps, and we're turning a little bit more than 90 degrees. If we turned 90 degrees, the pencil would have moved down, as we saw earlier with the square, but we are rotating the sprite a little bit more than 90 degrees, so that's 120 degrees. So it will move slightly backward, and then it will take this turn to complete this perfect triangle. So the lesson is that if you divide the 360 degrees, which is a full rotation, into a different number of repetitions, you will obtain a different perfect shape. Now, this is possible because 360 degrees, which is a full rotation, can be easily divided into either 4 equal parts, or in this case with a triangle, into 3 equal parts. But the number 360 is such a nice number, it can be divided equally in many, many different ways. So I'm going to right-click on the top of the B script, and I'm going to duplicate it. So I'm going to add another script. I'm going to say when the key C is pressed, I'm going to change the pen color to a different color. Say, for example, let's say this cyan color. I'm going to make it a little darker so that we can actually see it on the stage. And then I'm going to change the number of repetitions and the number of degrees that we are going to turn. Now, 360 degrees, if you know some math, can be easily divided into 5 equal parts, for example. So divided by 5, 360 degrees divided by 5 is equal to 72 degrees. Now, 5 equal steps means that we are going to create a different kind of shape that will have 5 sides of equal length. So I'm going to click the flag to free up my canvas, and I'm going to press in the C key on my keyboard or this script so that we see what kind of shape we obtain. So notice that this time we obtain the perfect pentagon. A pentagon has 5 sides of equal length and it's perfectly balanced. All right, so this is a pentagon. We can also do other kinds of shapes if we divide 360 by a different number. So I'm going to right click on the script, I'm going to duplicate it, I'm going to change the key here from C to D, for example. If you want, you can change the color. So I'm going to change it to this darker blue. And I'm going to divide 360 by the number 6 this time around. So if you divide 360 by 6, you will obtain 60 degrees. So notice that once we change the number of repetitions, we also need to change the number of degrees that the sprite will rotate. And in this way, we will obtain a shape that has 6 equal length sides. So if I hit the flag to clear up my canvas, I will obtain a perfect shape of a different kind. But notice in the previous examples with a pentagon and with a square, our shapes increased in size. So I'm going to decrease the number of steps so that our sprite doesn't exit the screen. So I'm going to move by, for example, 80 steps instead of 100. That doesn't change the perfect shape that we are going to obtain. We are simply going to obtain a smaller shape so that our pencil doesn't attempt to get out of the stage and risk ruining our shape. So I'm going to hit the flag again just to make sure, and I'm going to hit the D key on my keyboard. And notice that we obtained a different kind of perfect shape. This time it has 6 equal lengths. And the shape with 6 lengths, it's called a hexagon. And right here what we've drawn is a perfect symmetrical hexagon. Now we can take this further. We can divide the 360 degrees into a different number. For example, we can divide it into 8. So I'm going to right click and duplicate the script again. And I'm going to change the key pressed to the next letter, which is in our case E. I might change the color of the pencil, for example, to this orange color. You can change it to any color you like. And instead of 6 repetitions, I'm going to do 8 repetitions because 360 can be easily divided evenly among 8 different parts. And 360 divided by 8 is 45 degrees. Also, because the shape will be quite big, I'm going to decrease the number of steps to, let's say, 60 steps. The number of steps doesn't really matter, but if the shape is too big, our pencil sprite might try to come off stage, and Scratch will prevent it from drawing the shape that we wanted. So the sprite will never be able to go outside of the stage. This is why we decrease the number of steps here. Now, when we click the flag so that we clear the canvas over here and press the key E on our keyboard, or simply click the script, notice that we now have a different perfect shape. This is called an octagon because it has 8 equal sides. Now, if you remember street signs, if you remember how the stop sign looks like in an intersection, the stop sign looks like this. It looks like an octagon. All right, so this is how you can recognize an octagon on a street sign. It's a shape that has 8 sides. And in this case, we have a perfect symmetrical octagon. And there are many other shapes that you can try. I'm going to duplicate the script once more. So I'm going to right-click and duplicate. I'm going to change the key here to the next letter, which is F. I might change the color of the pencil, for example, this green color over here. And I'm going to change the repeat number. So 360 is also divisible by 10. And 360 divided by 10 is 36 degrees. I'm also going to decrease the number of steps so that the shape that we obtained is not too big. Maybe I'm going to make it 40 steps this time around. I'm going to click the flag to change my canvas to plain white. And then I'm going to hit the key F on my keyboard over here. So notice that we now have another kind of shape. This time we have 10 equal sides. A shape with 10 sides is called a decagon. A decagon has 10 sides, and in this case we have a perfect symmetrical decagon. Now I'm going to clear the canvas again, and I want you to notice something that's particularly interesting. Let me hit the flag again, and let me hit the B key to draw a triangle. Take a look at this shape, all right? This is pretty sharp. If I hit the flag and then I hit the A key, which draws the square is not as sharp as a triangle. If I hit the flag again and I hit C, the pentagon is a little bit less sharp than a square. If I hit the flag again and I hit D, we now have a hexagon. If I hit E, we have a octagon. And if I hit F, we now have a decagon. Notice that each shape becomes less and less sharp. It looks closer to a circle, all right? So the more we increase the number of equal sides in the shape that we want to build, the shape closely resembles a circle. So what if we had a shape with many, 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 many equal sides? What would happen then? Now, if we think about it, we might have a good intuition of where we're getting at. So here's what I'm going to show you. I'm going to right-click on the top of the F script and I'm going to duplicate it again. And this time I'm going to press the key G, the next letter of the alphabet. I'm going to change the color maybe to a purple or something like that. And I'm going to split our 360-degree full rotation into a different number of repetitions. And I'm going to pick a big number here. Instead of 10, I'm going to pick 36. And after I've selected 36, I'm going to decrease the number of steps. I'm going to say 10. And I'm going to turn a number of degrees that would give me 360 if I multiplied it by 36. Now, what's 360 divided by 36? If you know some math, that would amount to 10 degrees. So we are going to create a shape that has 36 equal sides, and the rotation here is going to be 10 degrees. Let's see what we get. So I'm going to hit the flag, and I'm going to hit the G key on my keyboard, or I'm going to click this script. So look at that. This shape over here with 36 equal sides looks basically like a circle. So this shape looks like a circle, but in fact we drew a shape of 36 equal sides where every side is very, very, very tiny. So when you look at it from afar, like we're doing it here on stage, we see a circle. But the computer knows better. So the computer behind the scenes drew a shape of 36 sides, but it looks like a circle to us. So the next time you see circles being drawn in video games or on websites or in design applications on your computer, know that the computer actually draws shapes like this with many sides so that to us humans, it's not really distinguishable between that shape and a circle. So we basically see a circle. And if you're curious about the mathematics of a circle or the geometry of a circle is essentially a shape with an infinite amount of very, very, very tiny sides. All right. So when you look at a circle, you can imagine it as a shape with an infinite amount of infinitely tiny sides. But that was in real life, so that was in reality. Now on computers, you can simulate a circle by creating these shapes with a large amount of sides. For example, like 36 sides equal to 10 steps each, and when you rotate with 10 degrees by every side. Now, one last thing before I end the video. Now that you know how to draw a circle, you can probably draw many circles in different positions. And I'm going to show you how you can arrange many circles in a very cute, interesting pattern, and it's perfectly drawn by the computer. Now, I'm going to go to my block section, which is something that we practiced in the previous part of our Scratch journey. You probably know how to create your own block right now, don't you? So I'm going to click this button here to make a block. I'm going to name this Draw a Circle. I'm going to hit OK. So I'm going to hit OK here. And the definition for the Draw a Circle block is going to be this implementation of this script. So I'm going to move these blocks to the Draw a Circle definition. And instead of the script that I used to have in the script when G was pressed on my keyboard, I'm going to bring in this Draw a Circle custom block. So when the computer sees the Draw a Circle block, it will actually execute the script that Draw a Circle is actually defined as. So right now we have nothing really changed. So if we hit the flag and hit the G key again on the keyboard, notice that the circle is still shown on the stage. Now, I'm going to make use of this custom block over here to have you draw many circles in a pattern. So here's what I'm going to do. I'm going to duplicate this script when G was pressed. I'm going to change the key to the next letter, which is H. And instead of drawing a circle, I'm going to draw many circles. And I'm going to borrow the logic that we used to have in one of these repeat blocks. So I'm going to bring in a repeat loop. So I'm going to say, from the control section, I'm going to bring in a repeat loop. And I'm going to repeat 8 times. And I'm going to bring this draw a circle block inside the repeat block. But on each repetition, after I draw a circle, I'm also going to rotate my sprite a little bit. Why is that? At the beginning, if you remember, the first line that the sprite draws is a horizontal line. And when it's drawing a circle, it draws a very tiny horizontal line. But what if the next circle that it's supposed to draw starts at an angle? For example, an angle that looks a little bit downward like this. So I'm going to go to motion and I'm going to bring in the turn block over here and I'm going to bring in inside the repeat loop and I'm going to turn by 45 degrees, the same amount of degrees, the same number of degrees that we used to have when we drew our octagon with 8 sides, except instead of drawing 8 lines, we are drawing 8 circles. So here's what I'm going to do. I'm going to click the flag now, and I'm going to press the H key on my keyboard or click this script on the code dashboard. So I'm going to click here, and notice that this time the script draws circles repeatedly in this very interesting pattern. So it draws exactly 8 circles in what seems to be this floral-like pattern. Now, I don't know about you, but I think this is pretty cool. So you have 8 circles disposed exactly symmetrically across the stage. And obviously you can change these numbers with 8 and 45 to the other combinations that we used to have when we drew our perfect shapes. For example, you can pick 4 and 90, such that the multiplication between these two should give you 360 degrees. So you have 4 times 90 is 360, the same as 8 with 45, the way we used to have, is still 360. So if I clear the stage and press the script again, notice that this time the sprite draws perfect circles which are symmetric across the stage. Obviously, you can pick the other combinations of numbers if you want other arrangements of circles. But I think you've learned a lot so far. So you've learned about perfect symmetrical shapes, and you've learned about how circles are actually represented on the computer, and you can now actually play with these shapes in interesting combinations across the stage. Alright, so thanks for following along so far. Join me in the next video where I'm going to show you some more interesting shapes.